Dear friends, welcome to a lecture on complex analysis. In this lecture, we shall study regions in the complex plane. We will see certain terms, we will define it, and then also we shall see the geometrical interpretation of these terms. Earlier we have seen what is the meaning of complex plane. Complex plane is a plane consisting of rectangular axes x and y, and complex number is denoted by order pair x, y. And that means if this distance is x, if the point is z whose coordinates are x, y, then the distance of this z from y axis is x and from z axis is y. So, it is the usual meaning. And now we shall consider the plane regions in this complex plane. I have written here definition of first as epsilon neighbourhood. What is epsilon neighbourhood of a given point z naught? Epsilon is a Greek letter which is used to denote small, and here we shall consider it as a positive real number, small positive real number. And epsilon neighbourhood of given point z naught is the set of all points z lying inside but not on circle with center at z naught and radius epsilon. Earlier we have seen that the equation, see, mod z minus z naught is equal to r. This equation represents a circle, this we have seen, and circle with center at z naught and radius r. That means it is a circle whose center is z naught and radius is r. And here and that means those points, this equation represents those complex numbers z which are exactly on the circle and not inside the circle. That means the distance of z from z naught, this distance is r. But what is this set epsilon neighbourhood is the set of all points lying inside but not on the circle. And what about the circle? The center is at z naught and radius is epsilon. So, that means we will have here the radius as epsilon and center is z naught, and the equation is now mod z minus z naught is less than epsilon. So, this represents all those points which are within distance epsilon from z naught, and that means inside this disk and not on the circle. So, lying on not on the circle but inside the circle, and the radius of the circle's radius is epsilon. Epsilon is positive real number, epsilon is real number and it is positive. So, this is the meaning of epsilon neighbourhood of z naught. That means those points of in the complex plane which lie within epsilon distance from z naught, that will be, these are infinitely many points which will be inside this disk and not on the circle or not on outside the circle. This will be the complex plane x y. So, this is this epsilon neighbourhood of z naught is this one. Mod of z minus z naught is less than epsilon. And what about deleted neighbourhood? Deleted neighbourhood, or which is known as punctured disk, is 0 strictly less than z minus z naught is less than epsilon. This consists all points z in epsilon neighbourhood of z naught except the point z naught. So, this point z cannot take the value z naught. Mod z minus z naught is strictly less than 0, and that means this z naught point is deleted, and in that case it is known as deleted neighbourhood of z naught. For example, if we consider say z naught as 2 and epsilon as 0.1. So, this will be 0.1 neighbourhood of 2, and that means all those points which are at a distance less than 0.1 from the point 2. So, this is the meaning of epsilon neighbourhood of point z naught. Next we will consider the further terms, we will define it. next we shall see what is interior point, exterior point of a set, and here I have written definition for interior point. A point Z0 is said to be an interior point of a set S whenever there is some neighborhood of Z0 that contains only points of S. Now that means if we consider, so this is what we have is earlier considered as epsilon neighborhood of Z0, and that is here. So what is meaning of interior point? Now if we consider a set S in the complex region, so that say set may be any set of this type, not necessarily circle, maybe any shape we may consider, and a point is interior point. The meaning is as usual simple. If it lies inside the region, then it is interior point, and that means the point must be like this. See, this point Z0 is interior because according to the definition there must exist a neighborhood of Z0 which is entirely inside the set S, and that means we can construct a neighborhood of this point around this point Z0 of radius epsilon, and that region, that neighborhood is entirely in the set S. Then this is interior point, or the point which is all these will be interior point which lie inside the region are interior point. And further, what about exterior point? A point Z0 is said to be exterior point of S whenever there exists a neighborhood of Z0, neighborhood of Z0 containing no point of S, and that point will be exterior point. Now that for example, if you consider this point here, the point, then this is exterior point of S because there exists a neighborhood of Z0 which contains no point of S, and so this is the meaning of interior point, this is exterior point. And a point which is neither an interior nor an exterior point is called the boundary point. Point of set S. If you consider the same set S, a point which is neither interior nor exterior will be the boundary point. And that point lies on the boundary. See this point, it is neither interior nor exterior point, because if you consider an epsilon neighborhood of this point, whatever small it may be, see it will not be entirely inside S or not outside the set S. That means this neighborhood does not contain only the points of S. This point Z0, the point, all the points we are denoted for sec Z0. Actually these are different points, and this may be considered as Z0, this is Z1, and this Z2. So Z0 is interior point, Z1 is exterior point, Z2 is boundary point, and the point which is neither interior nor exterior point and is called the boundary point. For example, if you consider, so suppose S is the set mod Z is equal to 2 is the set, and that means it will represent a circle with center at origin and radius 2. So we should imagine this, and this is 2. And now the point which is say 1 unit and this 1 unit, that means if you consider this point as Z0, the point will be 1 1, and that means 1 plus 1 I is interior point, then 1 plus I is interior point. Z0 is equal to is an interior point. point of S. And to consider an exterior point, we may consider this say any point. Here we may consider this as suppose this is 1 unit negative, and if you consider 3 unit, this is 2 and this will be 3. So that point is -1 3, and the point that may be denoted by Z1, this point Z1, which is equal to -1 plus 3i, is an exterior point. And now we may see the point, this point is the boundary point whose coordinates are 0, 2. Z2 is 0 plus 2i is a boundary point of S. So the meaning is according to the definition. We can construct a neighborhood of Z0, epsilon neighborhood of Z0, and which lie entirely inside this circle, entirely inside this disk, not circle but disk, that is mod Z less than 2. So actually we have to consider this as mod Z less than 2, and yes, mod Z less than 2, and then because we have to consider this disk. So all those points are interior of S, and Z0 is interior point. So this Z1 is exterior point, and Z2 is boundary point of this set S. So this is meaning of interior, exterior and boundary point of set S. Next we shall see what is open and closed set. I have written definition here. A set is open if it contains none of its boundary points. The set does not contain its boundary points. And a set is open. Another definition or condition, necessary and sufficient condition for open set is a set is open if and only if each of its point is an interior point. Then the set is open. Now for example, if you consider this set, mod Z is strictly less than 2, then it is open set because it does not contain boundary points. The meaning of this is, or this is also open set, epsilon neighborhood of Z0 is open because it does not contain boundary points. It contains all the points which are interior points of the set, and that means mod Z is strictly less than 2 means those points which lie inside this disk, not on the boundary of the disk, and therefore this set is open. For example, the sets, these sets, epsilon neighborhood of Z0 is open. This is first example, this is second. The set S is open because every point of this set is interior point. And what is the second definition of what is closed set? These are the important concept in real analysis also. We have studied this open set and closed set. So, or the meaning of open set is for every point of the set we can construct a neighborhood of that set which lies entirely inside the set. So, this point, see, around this point we can construct a neighborhood of this. That means those points which are up to distance epsilon from this point, that is neighborhood, epsilon neighborhood. And any neighborhood we have to construct such that the neighborhood must be entirely inside the set, then that set is open set. Or if you consider the point which is close to the boundary, not on the boundary but close to the boundary, then that we can construct a small neighborhood of this point, and which is such that it lies entirely inside the set. And if this condition is fulfilled, then the set is said to be open set. So, mod Z strictly less than 2 is open, or the annulus, see, 1 is less than mod z is less than 3, that this is also open set. What this represents? This represents annulus or ring shape. So this is suppose 1 unit distance from origin, and this will be, you may assume, see, this distance is 1 and this distance is 3. So it will represent 1 less than mod z less than 3 will represent those points which lie inside this ring, greater than 1 and less than 3. So this ring or annulus. This is our third example, is open set. So these are some examples of open set. And what is a closed set? A set is closed if it contains all of its boundary points. All of the boundary points must be inside the set, then it becomes closed set. Now how to consider the closed set? So neighborhood, epsilon neighborhood is always open set because there is strictly less than condition. So therefore that is open. But this set can be converted to closed set. If you consider this inequality as less than or equal to, then it becomes closed. So what is the difference between mod z strictly less than 2 and mod z less than or equal to 2? So this set does not include its boundary, but this includes the boundary of the disk, and that means those points which are within the disk and on the disk, whose radius from origin, distance from origin is 2. So this point is there, this is boundary point, all the boundary points are inside this. So this set is, the set is closed, this set is closed, or yes, we have written here. And what about the annulus? When the annulus will be closed? If you change the inequality to less than or equal to, then these boundary points will also be there, and then this region is closed set. So this is the annulus which is represented by this inequality, and if we consider the inequality less than or equal to strictly, then it becomes open, becomes closed set, and if the inequality is strictly less than, then it will be open set. That is the meaning. A closed set contains all its boundary points. And what about closure? Closure of a set S is the closed set containing or consisting of all points in S together with boundary of S. Now for example, if I consider mod Z is less than 1, this is open set, and but what will be closure of this set? The closure of this set will be mod Z less than or equal to 1, because closure consists of the points. It is a closed set consisting of all points, interior points along with boundary points. So the closure of mod Z strictly less than 1 is this set. So this is meaning of open set, closed set and closure of set. Next we shall see connected set, and here I have written definition. An open set S is connected if each pair of points Z1, Z2 belongs to S, can be joined by the union of finite number of line segments in S. That means these points can be joined by single line or a finite number of lines, union of finite number of lines. So that region is said to be connected. For example, if we consider the open set, then the open set we should consider as, say, mod Z is less than 3. This is open set, as we have seen earlier. The condition here, it must be strictly less than 3, and that is a disk. That is a disk whose center is origin and radius is 3. So, all those points inside this, and this is connected because each point in this region is connected, suppose Z1, Z2, then this is connected by a single line segment, this Z1, Z2, or if you consider, and so therefore this is connected, it's connected set. Now, second example, if you have this 2 mod z less than 5, 2 is less than mod z less than 5, and as we have seen earlier, this represents a annulus as like this. And you see this will be 2 unit from origin, and this is 5 unit. We have considered this annulus. Whether it is connected, now if you consider this point here, but that is not in the set, and now if you consider this point here as Z1 and another point you may consider here Z2, how to connect these 2 points? We cannot connect these points like this, because here the this region is not in this annulus, because the region is only this ring shaped. This is the region, but we can connect this Z1 and Z2 like this. See, in this way we can connect Z1, Z2 by union of finite number of line segments. Not here we have connected with in one line, and here we have used 2 line segments to connect Z1 and Z2. So, therefore, this set is also connected. So, this is the meaning of connected set. And what will be a not connected set if you consider this as say mod z is strictly less than 2 and mod z is greater than 3. So, this region will be not connected, because what is mod z strictly less than 2, that is this disk, and mod z greater than 3 will be the disk which is having the distance from origin greater, that distance is greater than 3, and therefore, this will not be connected. The set union of this mod z greater than 3 is not connected. Example of not connected set, because this will represent actually this is the set mod z less than 2, and if you consider this as 3 unit, it origin, and you see this is the disk first part of this set, and the second part will be outside this circle, and therefore, if you consider one point here and another point here, these points cannot be joined by a finite number of line segments which are entirely in this, because this portion will not be included in this set, and this is not connected. Now, further we define as a non-empty open set that is connected is called a domain. Non-empty, it is 2 conditions there are: open set and connected. An open set, it must be an open set and it must be connected set. So, then it is domain, and therefore, this is a domain, and also this annulus is also a domain. 1 less than 2 is less than mod z is less than 5 is a domain, but that the set is not connected, and therefore, that is not a domain. Further, a domain together with some, none or all its boundary points is referred to as region. Region, that is a domain that is a domain which contains some, none or all boundary points. So this is a domain which contains no boundary points, so this is also a region, and if it contains some of the boundary points, then that will be also a region, or this is also a region. Mod z less than or equal to 3 is a region. So these are the examples of connected set, domain and region. Some few terms we shall define in our next lecture, and also we shall solve some examples or to sketch the region. That is also important, to sketch the region that we have studied in this lecture. We will consider in our next lecture. Thank you for watching the lecture.